Welcome everyone. This is 15.1 on interior and exterior angles. And for the first part, we are looking at a triangle. Okay? So the interior angles of a triangle are the angles that are created on the inside of the triangle. Okay, those are the interior angles. And the sum of the angle measures of a triangle is 180, right? Degrees. Okay? Simple. So let's explore other polygons and their interior angle measures. Okay. We all know that a quadrilateral is, what's the interior angle sum of a quadrilateral? 360, right? We all know that it's 360 degrees. But the way we can think of it, class, on why it's 360 is if I pick a point and I try and draw as many triangles as I can, as many non-overlapping triangles as I can, right? If I draw something like this, yeah, you guys can see that this small triangle here is overlapping to that triangle right there. Yeah, so that won't work. So non-overlapping, the easiest way to create non-overlapping triangles is if you pick a point, and from that point, we're going to connect all the other points. Okay? So when I do that, there's two triangles, correct? Yeah. And we already established that one triangle is 180. So two triangles, 2 times 180 equals 360. Okay? So we're going to use that. So let's get the number of triangles here. Triangle has one triangle. We already said that quadrilateral has two triangles, right? One, two, non-overlapping ones. A pentagon, there's 5 sides here. So this is called a pentagon. Has, let's see, one line I can connect. I connect 2 lines, right? Like that. So there's 1, 2, 3 triangles. So there's 3 triangles here. This is a hexagon. 6 sides. So I can do something like that and get 1, 2, 3, 4 triangles. 6 sides equals 4 triangles. It's called a hexagon. Okay. How many sides does this have? 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yeah. So it's a heptagon. So it's 7 sides called a heptagon. Huh? I feel like I'm missing a letter. Mm, yeah, I am missing a letter. Heptagon. Okay. And how many triangles can I make here? Start from one point and connect the other lines or the other points to it. So that's 1, 2, 3, 4, 5. So there's 5 triangles. Okay, 7 sides creates 5 triangles. This is an octagon. Yeah. An octagon has 8 sides. Put it here. Has 8 sides. And if you start off with a point, right? There's 1, 2, 3, 4, 5, 6 triangles. Okay. Who sees the pattern? Raise your hand if you see a pattern. Between the number or the number of sides it has and the number of triangles I can make. Who sees a pattern? 3 sides, 1 triangle, 4 sides, 2 triangles, 5 sides, 3 triangles, 6 sides, 4 triangles, 7 sides, 5 triangles, 8 sides, 6 triangles. Raise your hand high. Okay. All right. Put it down. We're gonna go ahead and fill this out. Okay. And we'll talk about that pattern in a little bit. So a triangle has 3 sides, has 1 triangle. So it's 1 times 180, right? Equals 180. So that's the total sum. 4 sides, 4 number of sides is a quadrilateral has 4 sides, 2 triangles, so it's 2 times 180. Pentagon has 5 sides, and we said that it has 3 triangles. So it's 3 times 180 is, what is 3 times 180? Thank you, Daniel. 540. Yeah. Hexagon has 6 sides. It has 4 triangles. So 4 times 180 is 720. Decagon has 10 sides. How many triangles? I'm not going to try and draw a decagon. But how many triangles can it make with a 10-sided figure? 8 of them. So 8 times 180 is 1440. Okay. All right. So here, since you guys or most of us saw that saw the relationship between the number of sides and the number of triangles, there's a general formula that we can follow. Okay, so the sum of interior angles of any polygon is, if n is the number of sides, how many triangles, if I have n sides here, okay, and then put it n-sided polygon, yeah? I have no idea what n is, but then you can plug it in. Rumi. It, the number of triangles I can make is n minus 2, right? So to get the interior angle sum, it's going to be n minus 2 times 180. Correct? The number of triangles I can make, multiply that by 180 degrees. Okay? So yes, this is going to be my formula. That's it. Yeah. N minus 2 times 180 is the sum of all interior angles of any polygon. Okay? Cool. Number 6, we have this. Determine the unknown angle measures in the pentagon. What is the these squares mean? They're right angles, right? They're all right angles. What's the interior angle sum? $540 or 3 times 180, right? 540. So I know, class, that 540 is going to equal 90, check, 90 and 90, plus 90 plus 90 plus x plus x. Right? If I clean that up a little bit and simplify, 540 equals 270 plus 2x. Subtract 270 from both sides. That's 70. 170 equals 2x. So x is going to equal 85. Okay? Cool. Determine the measure of the fourth interior angle of a quadrilateral if you know the other three measures. And determine the unknown measure of a hexagon whose 6 angles measure this. I'll give you guys 2 minutes. Okay? And we'll come back in 2 minutes. Okay, so number 7, we have determined the measure of the fourth interior angle of a quadrilateral. So you know a quadrilateral has 360 equals, if the other three are 89 plus 80 plus 104 plus x, right? And x is what we have to figure out. So if you do this math, 360 equals 273 plus x, subtract 273. We get, what do we get? 87 equals x, right? Okay, number 8, it says to determine the unknown angle measure of a hexagon. Remember, a hexagon is 720 equals 69 plus 108 plus 135 plus 204 plus 3b, because b plus 2b equals 3b. So this would be 720 equals 3b plus 516. So subtract 516. Two hundred four equals 3b divided by 3 on both sides. So then b can be equal to 68. Yeah. Okay. Remember that. And then you can figure out the unknown angle measures by just plugging in 2 times 68, right? Which is 136. Okay. All right. Now, by looking at this picture, what can you conclude looking at the picture between the angles? So I'll give you guys another 2 minutes. Think about that. So we talked about this and we concluded that measure of angle 1 plus measure of angle 2 equals 180, right? Because they're linear pairs. I know that measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals 180 because they're all interior angles of a triangle, right? So if I get those two equations and I set them equal to each other, measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3 plus measure of angle 4, right? We can set them equal to each other because I know angle 1 is equal to angle 2 because they're linear pairs. And I know that angle 2 plus angle 3 plus angle 4 with whatever they're equal to, they are also equal to 180 because they're all interior of a triangle, interior angles of a triangle. So I set them equal to each other. Now I noticed that if I subtract measure of angle 2 to both sides, I would end up getting measure of angle 1 is equal to measure of angle 3 plus measure of angle 4. Okay? That make sense? Yeah. So here is the names of the angles. Angle 1, this is 1, this is 3, and this is 4. 1 is called the exterior angle because it's on the outside of the triangle. And the two other angles that are not linear pairs with the exterior angle is the remote interior angles. The way I remember this word, remote interior angles, is I am the exterior angle, yeah, and I want to control angle 3 and angle 4, so I use my remote. Okay, so they're interior angles, but they're remote interior angles because I'm using my remote to control them. Cool? So that's the exterior angle theorem. That's the exterior angle. Of a triangle is equal to the sum of the remote interior angles. Okay. All right. So I have these two as my examples to kind of help you out with this. So determine angle B, which is 5z minus 2, right? That angle right there. So using the theorem, this is my exterior angle. And these guys here are my two remote interior angles. Okay? So I know 145 is going to equal 5z minus 2 plus 2z. Okay? So we have 3z minus 2 equals 145. Add 2 to both sides. We have 147 equals 2z equals 3z, I mean. Divided by 3, divided by 3. That's 49 equals z, right? And then the angle that I'm interested in is angle B, which equals 5z minus 2. 5 times 49 minus 2. That would be 216 minus 2. No, that's not 216. 245 minus 2, which is 243. Okay. Yeah. Oh, why did I subtract 5z and 2z? I should have added them, huh? That's 7. So I will still add 2 to both sides. 5z plus 2z is 7z, not 3z. Divide that by 7, you get 21. So it changes up the answer, but you guys understand the process, right? So this would be 5 times 21 minus 2. 105 minus 2. 103. Okay. All right. And that is the lesson for today, class. That is 15.1 on exterior and interior angles of a triangle.